Okay, so today we're going to talk about circles and arcs. Let's dig right in. So we want you to learn to be able to find the measure of central angles and arcs, and we want you to learn to find the circumference of a circle and as well as arc length. And these terms probably mean nothing to you because we haven't defined them yet. We'll get right at that now. Okay, so here's a huge page of definitions. A circle, and let's just kind of outline this here. This is the one we're at now. A circle. In a plane, a circle is a set of all points equidistant from a given point, and that given point is called the center. So as you can see right here, we have a circle, and all the points in this circle are the same distance away from the center B. Okay? So that's what a circle is. Next one we want to talk about, a radius. A radius is a segment that has one point at the center of a circle, like B, and another point on the circle, okay? So BC is a radius of circle B. And by the way, when we name circles by their center point. So we would say this is circle B. And see how we draw a circle with a center point, and that we indicate that center point is B. Now let's talk about congruent circles. Congruent circles are circles that have congruent radii. Okay, so we're on this term right now, congruent circles. So congruent circles have congruent radii. So if you have the same exact measure for a radius, you're going to draw the same size circle. Next one. Oh, we'll do some orange here. Diameter. A diameter is a segment that contains both the center of a circle and has both endpoints on the circle. So if we are looking at a diameter in this diagram, AD, segment AD, is the diameter, measures the diameter of circle B. And finally, a central angle. So a central angle is an angle whose vertex is on the center of the circle. So if we're looking here, we could say angle CBD is a central angle of circle B. We could also say angle ABC is a central angle of circle B. Or angle ABD is a central angle. Okay? So there's some of your definitions. But since we're just starting talking about circles, we have yet another page of definitions. So an arc is a part of a circle. So when we have an arc, like arc AC, okay, that's one arc that we could have. A semicircle is half of a circle. So arc AD is a semicircle. And a minor arc versus a major arc. This is kind of like acute versus obtuse with triangles. So a minor arc is smaller than a semicircle, which means it's less than 180 degrees. And a major arc is greater than a semicircle, so that means it's greater than 180 degrees. Okay. Now we know the arc measure of a semicircle is 180 degrees. And the arc measure of a minor arc is going to be equal to the measure of its corresponding central angle. So if we're talking about a minor arc, something less than 180 degrees, then the measure of the arc is going to be equal to the central angle measurement. So it's like with angle or arc AC, angle ABC is the central angle that helps form arc AC, right? So since angle ABC has a measure of 120 degrees, arc AC has a measure of 120 degrees as well. So in measuring an arc, what we're really doing is saying how many degrees worth of that full circle of 360 degrees does this arc make up? Okay. Now, when we have a major arc, measuring it is a little bit different. So if we were talking arc ADC, right, going around this side of the circle, then we would want to measure that by taking 360 degrees minus the measure of its related arc, AC. So the measure of angle of arc ADC is going to be 360 minus 120, which is 240. Okay, so we take the major arcs and say, okay, if we take out that minor arc, the whole circle minus the major arc is going to equal the minor arc. It's complicated to explain. It's not complicated to explain. I'm just mucking it up. Okay. So if we want to measure this big one, then we take the 360 minus the little one gives us the big one, if that makes sense. Okay, so let's talk about the arc addition postulate. The arc addition postulate says the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if I have arc IJ and arc JK, and these are both formed by central angles, they're minor arcs, and so we can just see that the measure of this arc is 90, the measure of that is 110. Well, the measure of arc IJK then is going to be 200 degrees because it's the measure of the two little arcs. And that, of course, makes sense, but we need to spell that out so that you know that really that is how it works. So, looking at this, we can find some arc measurements, okay? So, we want to measure the arc HI. And if we can see here, HI is right here. It's got a central angle of 60 degrees. It's a minor arc, so this arc will also measure 60 degrees. Let me get you a darker color here, 60 degrees. Now, arc HS. If we look at this, we can see that arc IS is 180 minus this arc IH or HI will give us 120 degrees for arc HS. Arc SN. Well, arc IN is 90 degrees. Arc IS is 180, so that means arc SN must be 90 degrees. Now HSN, remember we said this was 120, this one is 90, so arc HSN should be 90 plus 120, which is 210 degrees. Okay? Now arc HSI is going to be 360 because we're going from arc H all the way through S all the way over to I, so that's going to be 300 degrees. Now let's solve for some arc measures. Here we have a circle, and we can see that we have a diameter here. Arc SA is a diameter, and we want to solve for the measures of these arcs, and we have two expressions that helps us equal to them, that tells us what they're equal to. So we know that these two expressions, 4x plus 3 added to 6x minus 13, will add up to 180 degrees. So with this, we can solve for x and then solve for the different degree measures. So we have 10x minus 10 equals 180 degrees. This is a degree thing. So we'll have 10x is equal to 190 degrees. So x is equal to 19 degrees. Now, that's nice. What we can do with this now is plug in 19 degrees into each of our expressions to find out the measure of the associated angles. So 4 times 19 plus 3 should give me the measure of arc PS. So that should be 4 times 19 plus 3, which is 79 degrees. So arc PS measures 79 degrees. Next one, 6 times 19 minus 13 should give me the measure of arc AP. Okay, so 6 times 19 minus 13 gives me 101 degrees. measure of arc PS. And you notice the two do add up to 180, which is our check to make sure we did this right. So this one was 79 degrees, this one is 101 degrees, and all told, with this 180 degrees, we get a full 360 degree circle. Now let's talk about circumference. Theorem 7-13 says the circumference of a circle is pi times, not dimes, times the diameter, right? Now, the diameter is 2 times the radius, so we have two formulas that we can use to find the circumference of a circle. And the circumference of a circle is the perimeter of a circle. So it's a distance around that circle. So we can either multiply the diameter times pi or 2 times the radius times pi to get our circumference. Another thing we want to do is talk about is arc length. Theorem 7-14 says the length of an arc of a circle is the product of the ratio measure of the arc divided by 360 degrees and the circumference of the circle. Okay? So this one was a little bit tough to write out before I started. So the measure, or sorry, not the measure, the length of an arc, call it AB, is equal to the measure of AB, meaning the degree measure, divided by 360 degrees times 2 pi r. So what are we doing here? We are saying we want to find the ratio, what percentage of the circle we're dealing with here. My arc divided by 360 degrees tells me what percentage of that circle I am talking about. So that percentage times the full circumference of the circle will give me the length, not in degree measurement, but in whatever units we use for our radius of that, around that part of the circle, okay? So since an arc is part of a circle, we figure out the ratio, how much part of it is, the degree measurement of our arc out of that 360 degree circle times the circumference gives me the actual measure of that circle, or arc, sorry. So what we've learned the different parts of a circle, the arc addition postulate, how to find the circumference of a circle, how to find the arc length of a circle, and what congruent arcs are. Did I cover congruent arcs? I'm not quite sure. I think I meant to, and I don't think it's saved on this. So congruent arcs, since I don't have record of that. Congruent arcs are arcs that have the same measure and are in the same circle or in congruent circles. So if I've got a circle here and we've got the same radius as another circle over here, right? And the arc length is also the same. I don't know if you can really do that, but then those are congruent arcs. I'm really kind of feeling guilty too about not getting you an example problem. So let's give you an example problem. So we're going to have a circle here. And this is circle A. And I am going to give you an arc, and that is 72 degrees. And this is arc BC, right? And I want you to find, and we have a radius equal to 3 centimeters. I want you to find the arc length of arc BC. Well, that's going to be, so the length of BC, arc BC, is going to equal the measure of angle, or the measure of that arc, which is 72 degrees, divided by 360 degrees, times 2 times pi times my radius, which was 3 centimeters. Now, one thing we do need to note is that you need to leave this in terms of pi, okay? So we don't want you to really multiply out that 3.14 times anything. That is totally unnecessary. So 72 goes into 360 5 times, right? So 1 and 5. 2 times 3 is 6. So we have actually 6/5 pi centimeters. So that is actually 1.2 pi centimeters is my arc length. Okay, and we would actually leave that in terms of pi there. Okay, now if you want to approximate it, you can multiply it by 3.14, and you'd get that it's approximately 3.77 centimeters long of that arc. And so that distance is what we're measuring from B over to C on a 3 centimeter radius circle. Okay? So I hope that helps you. There's a couple other examples on arc length in the book that you can look at, but I just wanted to give you one more here. That's it for now.